Hello solvers, welcome to your sessions 9 and 10, the last 2 weeks before schools close in New Zealand and we get a 2-week holiday. So William, I'm going to email Mom about that. All right, moving on, this time for puzzles, it is your turn to create. So what you have to do is look back at all the examples of the shape and space puzzles. So we're not talking about number puzzles here. We're talking about shape, space, logic puzzles that you have solved over the last 8 weeks in Go. So then you have to create 3 puzzles, starting with easy, medium, and challenging. But you make sure that you know how to solve these puzzles. So if we can't and get stuck, you can show us how to. Post your puzzles in a blog post for week 10's class if you can. If you can get this activity done next week, then we can have some fun looking at each other's puzzles and trying to solve them. Okay, that would be a good way to spend a part of week 10's lesson. Awesome. So that's your first activity. You are the creators. Now we are carrying on with our shape space concept in geometry, but we're looking at a concept called topology. Okay, now topology is a bit abstract and can be a bit challenging to understand, but we are going to keep it simple and try our best to understand what is it. First of all, if we're looking at the language of the discipline, the language of mathematics, topology is the study of properties of geometrical properties like shape, sides, space, corners, etc. But it's more a relationship of space with each other. So, for example, the way a house is laid out, the rooms in a house are laid out, and the way one room leads into another through a doorway, these things fall under the discipline of topology, believe it or not. So, how the objects or things are structured in terms of positioning. And it also studies how different spaces are connected to each other. So sounds rather vague, but as we get into it and look at a few activities and videos, we'll get a slightly clearer idea of topology. Now, topology is also used by computer scientists, but we are not looking at that. We're just looking at the mathematical geometric part of topology. Okay, so the first one is you creating your puzzles. Activity 2, here is a watch, think, learn activity that introduces topology to you in as simple terms as possible. Go back to this video again and again and again as many times as you need to, every time you get confused. So you don't have to do a blog post for this one. However, after watching in activity 3, you do a blog post. You write down some 3 and no more than 5 unanswered questions about topology from the video. Okay. Activity 4, let's learn about a Mobius strip. Now, Mobius strip is language of the discipline. It is something that's very common in topology and topology puzzles. Okay. Then create a blog post to answer these questions after watching the video. And this is not the video. This is just a picture of the Mobius strip. A Mobius strip is a surface with only one side and one edge. Such shapes are an object of study in topology. What are the questions? Can you describe a Mobius strip in your own words? Here is the description. Can you simplify it? Say you're explaining a Mobius strip to a 6-year-old. How would you describe it? Are there any everyday objects around the house lying around that remind you of the Mobius strip? Sometimes it's called the Mobius band. There is a symbol that is universally used to indicate reusing something. That symbol is actually designed on the Mobius strip. That is wrong. So that symbol that I'm talking about is universally used in all countries of the world, and that symbol indicates reusing something. That's the clue I'm giving you. It's based on the Mobius strip. Can you guess what that symbol is? Hint, the symbol is green in color in every country. Okay, a video to watch. This is computer animation. It shows the Mobius strip in operation. Fascinating to watch. Activity 5, it is your turn to do some hands-on experiments with the concepts of topology and Mobius strips. Watch this video below and try to repeat at least 2 of the experiments. Now, this gentleman here is a mathematician, very clever. He actually gets hands down on the floor with Mobius strips, and he shows us all kinds of things we can do. And the fascinating way Mobius strips and any shapes actually, he cuts through them. You've got to watch it to see what he does. Okay, but try to repeat any 2 of the activities if you may. And then if you take photos of you doing it or a video of yourself doing it, if mama dad can help you do that and upload that, that'll be great. If it's photos, see if you can label your photos. That's activity 5. Activity 6 is a self-paced activity for you to take your time and have some fun with. You do not have to make any blog posts, but if you enjoy the activities and try some of them out and want to upload photos and videos, please feel free. Use the school holidays to continue to experiment if you choose to. Let us look at the amazing mathematical magic shapes. Mobius strips, paper clips, and rubber bands can do. So he does some magic. You know how, yeah, I won't give too much away. So same gentleman, he has got a series of videos. As I said, this is an optional activity. You watch it, but you don't have to do the activity. Even if you do it, you don't have to put a blog post up, but you can if you want to. Because these activities will take time, you having to do your puzzles and you having to do your Mobius strip activities, plus watching this takes time. I have not given you too many. I've given you 6 activities, but they are all topological. So have fun, enjoy, and I am going to see you in class and see if you have any clarifications, any doubts. Okay, cool.